Hello, everyone. And today we're going to talk about coordinate geometry. I have done this webinar at least 3 times before, so if you want some more of coordinate geometry, you can always go back to our YouTube channel. Um, you can always access the board through the link. You can follow what's going on, and let's get started. Well, so let's first of all talk about the basics and kind of what's the idea of coordinate geometry. Well, why do we need it? Well, when you are trying to position something on on a graph or on a piece of paper or like on a map, you want to know where something is. So you want to know the coordinates. And we are very familiar with the Cartesian coordinates, the Cartesian coordinate system with x and y, and you can any point on the plane is defined with its coordinates x and y. And if there's another point like B with coordinates x2, y2, this is x1, y1, this is x2, y2, then we kind of want to be able to figure out, some easy things. Like, for example, how far is it from A to B, right? If we just know the coordinates, it would be good to know how to find the distance between A and B. And that's where the distance comes in. Distance is the square root of x1 minus x2 squared plus y1 minus y2 squared. I don't think I'll be doing proofs today. So I have done this proof before in one of my previous webinars. So comes from the Pythagoras theorem. If you draw a right angle triangle and you see that one side is x1 minus x2, the other side is y1 minus y2, then if you square them, you get the square of the distance. There are all sorts of things you might want to consider when you're talking about 2 points on a plane A and B, right? So maybe you're interested in, well, if I draw a straight line from the origin to A, if I draw an origin to A, and I draw a straight line from origin to B, what kind of angle is this, right? So this kind of thing. So why would it be useful? Uh, no, assignment scores do not go on your final certificate. Okay. So if you have a line OA and OB, what's the angle between them? That might be useful. So, for example, if you're building a something, right? You map the area you're building on with coordinates x and y, and then you might want to draw lines, or you might want to build a wall in that direction. So there's all sorts of useful applications when you're working. So it's much more than just sorry, much more than just points on a piece of paper, right? It's not more just what you do in the math class. For example, my wife is a civil engineer, and she used to design cities or design towns, and what they do is every point in the city has its coordinates correct to the nearest millimeter. So what you do is you say that at this point, so if you want to build something, you say I want to build I want to build a bridge from this point to this point, and everybody understands what you're talking about because they all have a map and they all talk about the same coordinates, and it's pretty cool. It's actually 3D because you also need the heights. And if you ever saw people walking in with these sticks which looks like cameras on top, so what they're doing is they are measuring the reference points, and they are updating those maps, those 3D maps of the city or town where you live in. So it's quite fascinating if you think about like yes, everything is mapped, everything has coordinates. You can have Cartesian coordinates with x and y, or you can have x, y, and z, of course, 3D, or you can have polar coordinates um, with a distance and an angle, or you can have spherical coordinates. Like, for example, if you want to know where you are on the globe, you want to know the spherical coordinates of your location rather than just x and y, right? Okay, so all sorts of things. We're not going to do the angle. Well, we will do some angles, but not in a clear way. But there is a formula. If you if you wish, I should I give you the formula? Okay, I'll give you the formula. I won't explain to you how I got there. So cos theta is going to be x1 x2 plus y1 y2 divided by divided by square root of x1 squared plus y1 squared, square root of x um 2 squared plus y2 squared. Okay, this is how you find the angle, but it's not important. It's not important today. Okay, so we're not going to do that. So distance, this was just a for instance. So the next bit, what would you be interested in? Well, it would be interesting to know the gradient of the line BA. So gradient of line BA is y2 minus y1 divided by x2 minus x1. And it doesn't matter which way you do it because you could also do it as y1 minus y2 divided by x1 minus x2. The result is the same. It doesn't matter which way you go. Okay. Now, what else? Gradient. The gradient has an important meaning. If you draw a line through that and label this angle as, well, we've used theta already. Let's call it alpha. So gradient is actually the tangent of alpha. But if it goes down, it's negative. Of course, it's alpha. So gradient is the tangent of the angle between the line and the positive x-axis. So sorry, I confused you. It's not this angle. That doesn't make sense. It's this angle, alpha. Gradient is tan alpha. Yes, that makes sense. So it's the angle between the line and the positive. So always counted counterclockwise, counted anticlockwise, from positive x-axis. Okay, I hope that makes sense. Right, so there are all sorts of applications for coordinate geometry. Then a straight line can be drawn, and you probably know that. I don't need to explain that. Mx plus c. Parallel lines, if two lines are parallel, then m1, the gradient of the first line is equal to the gradient of the second line. If two lines are perpendicular, then m1 multiplied by m2 is -1. So these are the conditions for parallelity and okay. So hope that makes sense. So this is a quick intro just of what we're trying to do today. And let's get to do some problems because that's the interesting part, of course. Right, so points A and B have coordinates 2, -1, and P5. When you're doing problems, you don't have to draw a coordinate system. Sometimes it's just enough to draw A is 2 -1 and B P5. But I I suggest that you do draw things, but not necessarily on a coordinate plane. And then given that the distance, find the possible values of P. Okay. So the distance is 2 square root of 13. So you want to know P. Okay. Oh, interesting. P5. I think there will be two possibilities. So let's have a look. We know that the distance from A to B is the modulus of AB, modulus of vector AB, is the square root of 2 minus P squared plus -1 minus 5 squared. And we know that this is equal to 2 square root of 13. Right. Now, I don't like square roots, so let's get rid of the square roots. I get 2 minus P squared plus the -1 minus 5, that's -6. -6 squared is 4 multiplied by 13, so that's 52. Now, you might be tempted to open the brackets. Let's hold that thought. Don't open brackets until you realize that it is necessary. There's no other way you can do it. So 2p squared plus 36 equals 52. Oh, that doesn't make any sense. Oh, yeah, it does. Sorry. 2 minus p squared, of course, is 52 minus 36, which is 14, 16. Okay. So after all, we didn't need to open the brackets because now we can just take the square root of both sides. Square root both sides and 2 minus b. Now, it's important in this step not to forget that there are two possibilities. There's plus or minus 4 because uh, 4 squared is 16 and minus 4 squared is also 16. So from here, we can write that p is 2 plus minus 4. So p is either 6 or p is -2. So there are two possibilities, and that makes perfect sense because if you think about it, if A is 2, 1, so 2 minus 1, and then this one is 6, 5, 6, 5, and this is -2, 5. This distance is 2 root 13, and this distance is 2 root 13. So they're both equally possible, equally possible. And then we can find the midpoint. It does say midpoint, but it doesn't ask for the midpoint. But let's do the midpoint. Midpoint. We know that the midpoint has coordinates m x1 plus x2 divided by 2, y1 plus y2 divided by 2. But there are two possibilities, right? Because we can have the midpoint m1 or the midpoint m2. So m1 is going to be 2 plus 6 divided by 2, comma, -1 plus 5 divided by 2. So m1 is 2 plus 6, 4, 4, 2, 4, 2. And m2 has coordinates -2 plus 2 over 2 and 5 minus 1 over 2. So that's m2 has coordinates 0, Lovely. So now we know the coordinates of the midpoint, 0, 2. Brilliant. Yes, this is the formula for the midpoint. Let's copy that in. All right, moving on. Gradient and perpendicular lines. So line L1 passes through point P and Q. All right, so let's say P has coordinates -3k and Q has coordinates 5, 7. And so that is line L1. And line L2 has the equation 4x plus 2y equals 3. Okay, that doesn't help too much. Given that L1 is perpendicular to L2, find the value of k. Okay, so we know that L2 is perpendicular. L2 and the L2 has coordinates 4x plus 2y equals 3. And there's 90 degrees here. Right. So the first thing, let's see what is perpendicular. Lines are perpendicular if the gradients are multiplied to -1. So we can find the gradient of line L1. So gradient of line L1. And we use the formula y2 minus y1 divided by x2 minus x1. And so that's m1. And that is 7 minus k divided by 5 minus 3. So that's 7 minus k over 8. That's the gradient of line L1. To find the gradient of line L2, so L2 has equation 4x plus 2y equals 3. To find the gradient, I'm going to rearrange to make y the subject. So 2y equals minus 4x plus 3. And y is minus 2. Okay, minus 2x plus 3 over 2. So gradient of line L2 is m2, which is -2, because that's the gradient. Okay, hopefully that makes sense. M2, so we have m2 and we have the gradient m1. M1. And now we know the lines are perpendicular. L2, L1 is perpendicular to line L2 if m1 multiplied by m2 is -1. So 7 minus k divided by 8 multiplied by -2 is -1. So we can simplify. Let's multiply everything by 4 by -4. And you get 7 minus k equals 4. And k is 7 minus 4 equals 3. K is 3. Lovely. So we found that P so answer K is 3. So the points are -3, 3 and 5, 7. Okay, let's just check. Can I check in with you, please, in the chat? Tell on a scale of 0 to 10, how well do you understand the solution to this problem 2? Okay, so 0 being I have no idea what we're talking about, and 10 is I understand fully. Okay, good. Because it was quite quiet, so I wasn't sure. All right. Got. All right. Okay. Equation of. Thank you. Thank you. Let's move on. So let's move on to problem 3. Equation of a line and area. A straight line L passes through point 6, 0 and is perpendicular to the line with equation 2x minus 3y plus 5. Okay, I think for this one, we can just we can okay. Let's let's do it using a proper coordinate system. Sometimes we do need to use a proper coordinate system. Not necessarily in this case, but just okay, 6, 0. So 1, 2, 3, 4, 5, 6, 6, 0. So this is point A, 6, 0. This is X, and this is Y. Now, this line, now you might be tempted to say, okay, let's let's rearrange it to make y the subject and then find the gradient and find the y-intercept. Yes, that's a good method, but to draw a straight line, you only need 2 points, right? So to so you have 2x minus 3y plus 5 equals 0. So what if x is 0, then then minus 3y plus 5 equals 0. So 3y equals 5, y equals 5 over 3. Oh, so if x is 0, y is 5 over 3. Oh, that's nice. 5 over 3 is 1.605 over 3. That's 1 point. And then if y is 0, then we have 2x plus 5 equals 0. So x is minus 5 over 2. So minus 5 over 2, 0 is also a point. So minus 5 over 2, that's here. So this straight line goes like this. So rather than trying to rearrange it and find y, we just find 2 points. Any random 2 points. Well, I've used the easiest ones, right? I took 0, 0. So this is minus 5 over 2. That's a good way of drawing straight lines, especially if it's not given in the standard form. Okay, so this is 2x minus 3y plus 5 equals 0. And what's the next thing? The line LL intersects the y-axis at point B. So a straight line passes through the point A, and it's perpendicular. Okay, so line L goes like this. Line L. The line intersects. Okay, find the equation of the line L. Um, well, we know that they're perpendicular. That means gradient of 2x minus 3y plus 5 equals 0. Well, 3y is 2x plus 5. Y is 2/3 x plus 5/3. So gradient is 2/3. Gradient of L, of the line L, is, well, is m. And so 2/3 times m has to be minus 1. So m is minus 3 over 2. So line L has gradient of minus 3 over 2. Now, if a line passes through, okay, let's make a note of this because that's important. If a line with gradient m passes through point x0, y0, then the equation of the line is y minus y0 is m multiplied by x minus x0. Right, that's a very important formula. So we can use that formula here. And if a line passes, well, I already said that. So for line L, we know that the gradient is 2/3, and we know that it passes through point 60. So we just use y minus 0 equals m, which is minus 3/2, multiplied by x minus 6. And all I need to open the brackets, y is minus 3/2x plus 9. And that's the equation of line L, minus 3/2x plus 9. And that means that it cuts the y-axis at point 9, yes? Because it cuts the y-axis at the point where x is 0, and that means it's 9. So it's 0, 9. It takes the y-axis at point B, so that's point B. Calculate the area of the triangle OAB. This is OAB. Well, that is straightforward. Area of triangle OAOB. Well, we know that this side is 9. We know that this side is 6. And we know that the area is 1/2 base times height. So 1/2 multiplied by 6 multiplied by 9, which is 27. That's it. That's the answer. Okay, hope that makes sense. And let's move on. Angle between two lines. All right, I like this one. Angle between two lines using gradients. So two lines, L1 and L2, have equations this. Find the acute angle between the lines L1 and L2, giving your answer to 1 decimal place. Okay, so we have a straight line, and it has a gradient of 1/2. 1/2 plus 3. So 1/2 plus 3, so it's like this. So this is line L1. And the equation is y equals 1/2 x plus 3. The second line has minus 3x plus 1. So this is 3, so minus 3. So it's quite a steep line. Right. Interesting. Remember what I've spoken before. L2 is y equals minus 3x plus 1. If you take the gradient of a line, so this is y2 minus y. Well, the gradient is change in y over change in x. Change in y over change in x. And if you take this angle, theta, then tangent theta is delta y over delta x, which is the gradient. So if we draw a straight line, so if you draw this angle, theta, let's call it theta 1. So we can say that tangent of theta 1 is the gradient of L1. Tangent theta 1 is the gradient of L1, which is 1/2. So if tan theta 1 is 1/2, then theta 1 is arctan 1/2, and which is approximately arctan, where I'm in radians, so let's switch to degrees. Arctan of 0.5. It's approximately 30. It's 26.6 degrees. Okay. So for the second angle, I know that the angle between the positive x-axis and the line is theta 2. So this angle is theta 2. So tangent theta 2 is the gradient of L2, which is -3. And so from here, theta 2 is, well, there's a problem with theta 2 because arctan will give me a negative value. Um, right, arctan, it's going to be 180 plus arctan -3. Well, look, it's just, look, arctan -3 is going to be a negative value, which doesn't make any sense. I mean, it does, but -3 is -71 degrees. So whereas -71, -71.5, 75.6 degrees. Now, what does that mean? Well, that's actually this angle because we count, remember, we count anti-clockwise from X. So counting clockwise makes it a negative, so -71.6 degrees. So the easiest way to do it is just to say 70 minus 71 plus 6 plus 180. That's why I'm adding. So it's 180 minus 71.6. 180 is 108. It's 108.4 degrees. Okay. 108.4 degrees. And now we need to find the acute angle between them. And well, it kind of gets very obvious if you draw a line here. You know that this angle is 26.6 degrees. And we know that this angle is 71.6 without the minus. Like we don't, and then we just add the two, the angle, angle between L1 and L2 is 26.6 degrees plus 71.6 degrees, which is minus 26.6, 98.2 degrees. Lovely. That's it. Oh, that's not an acute angle. That's obtuse. Okay, that's obtuse. So we need the other one because if this angle is 98, then this one is 180 minus 98.2. So the acute angle is 180 minus 98.2, which is 81.8. 81.8 degrees. Lovely. And that's the answer. Right. Hope that makes sense. Like moving on. Okay, we're halfway through and we spent half the time, so it's lovely. Locus of a point, a circle. A point Pxy moves such that its distance from point A is always twice its distance from point B. Okay. So we have a point A, which is -2, 4. And we have a point B, By the way, equation of a circle. Let's make a note of that. So a circle is a set of points, equidistant, equidistant from a given point. Yeah, equidistant from a given. Well, not equidistant. I don't need fancy words here. Set of points at a fixed distance from a given point. Okay, so let's say you have a circle of radius r, and the center of the circle is x0, y0. So x, y is a random point on the circle. So x0, y0 is the center, and xy is any point on circle. And r is the radius, of course. Now, then we know that the distance from is always radius, is always fixed. So we can say that x minus x0 squared plus y minus y0 squared square root must equal to the radius of the circle. In other words, x minus x0 squared plus y minus y0 squared equals r squared. That's the equation of a circle with at center x0, y0 and radius r. And this is equation of a circle. And let's check if that is in fact correct. So just for example, x minus 2 squared plus x minus 2 squared plus y minus 3 squared equals 4 squared. And you can see it is in fact a circle with radius 4. That's the radius. And the center is center is 2, 3. 2, 3. And the radius is 4. So x0, y0 is 2, 3. And radius is 4. So that's the equation. Okay, hope that makes sense. Did you already know about the equation of a circle? Yes or no? In the chat, please. Are you familiar with the equation of the circle? Okay. All right, so okay. Now, then it says we have a given point A and a given point B with coordinates 1, minus 2. And we have a set of points P which are with question 4 you could subtract, yes. You could subtract theta 1 from theta 2, of course. Theta 1 from theta 2 from theta 1. Now we know that this distance and these distance are related. So it says that the distance from point A is always twice. So the distance from PA is always twice the distance from B, PB. So in other words, PA is double PB. So if that is small, if this is A, then this is 2A. So double the distance. And the point P is allowed to move, but keeping that ratio constant. Right? So if it's on the line joining here, then it's somewhere here, and yeah, and so on. Okay, 2PB. Now, so now PA, the distance between P and A, it's x minus 2 squared plus y minus 4 squared square root equals 2 times the square root. PB is x minus 1 squared plus y minus 2 squared. And now we square both sides. Square both sides, and we get x plus 2 squared plus y minus 4 squared equals 4, open bracket, x minus 1 squared plus y plus 2 squared. Okay, and now we have to open the brackets, fortunately. So x squared plus 4x plus 4 plus y squared plus 8y plus 16, minus, sorry, that equals 4, open bracket, x squared minus 2x plus 1 plus y squared plus 4y plus 4, open bracket, so it's going to be 3x squared minus 8 minus 12x plus 4 plus 4. Ooh, that cancels with this. That's nice. Plus 3y squared, and then 16y plus 24y, and then 16 equals 0. Slightly annoying, but okay. We can divide the whole thing by 3, and we get x squared minus 4x plus y squared plus 8y equals 0. Now that doesn't look like an equation of a circle, but we can complete the square. We can write x squared minus 4x plus 4. That's what we need to complete the square. And then we're at minus 4. I hope you know how to complete the square, so I won't pause too much here. Y squared plus 8y plus 16 minus 16 equals 0. And then we wrap it up, x minus 2 squared plus y plus 4 squared equals 20. So this is a circle center 2, -4, radius square root of 20. How lovely is that? And let's see if that is x minus 2, y plus 4 plus 4 equals 20. And so that's a circle. So that's a circle to -4. So that's 2, -4. And a radius is 20. And let's check. So the given points were minus 2, minus 2, 4, minus 2, oh, wow, 4, minus 2, 4, and 1 minus 2, 1, negative 2, 1, negative 2. Okay, and you can see that for any point, this distance is double that distance. Does look like it. So from this point, this distance is double that distance. So if this is A, this is 2A, and this is B, this is 2B. It does look correct. You can check. You can check if that is true, but does look like it. Okay, the next one, tangent to a circle. So we've got 3 questions left. Lovely. Looking to finish 7:15. Tangent to a circle. So a circle has equation this, and find the equation of a tangent to the circle at the point 4, 0. Ah, I see. Okay. So you have a circle. The center of the circle is 1, negative 4. And the 4, 0. So somewhere here, 4, 0. A point P. And we want the equation of a tangent to the circle. Equation, so L is question mark. Now, well, what do we know? Well, we know that the line passes through this point. So line L passes of 0.40. That's the first thing what we know. What do we know? We know about L. But that's not enough because there's infinitely many lines that can pass through a given point, right? So you either need 2 different points or you need a point and a gradient, right? So if to find the gradient, we're going to find the gradient of line OP. So gradient, we don't know. So we start by finding step 1, find the gradient of OP. Gradient of OP. And the gradient of OP, MOP, is so y2 minus y1 over x2 minus x1, which is 0 plus 4 divided by 4 minus 1. So it's 4/3. If the gradient of OP is 4/3, that means the gradient of L is ML is minus 1 over 4/3, which is minus 3/4. All right, so that's the missing piece of the puzzle. We now know the gradient. The growth is minus 3/4. Once we know this, we use the equation. Equation y minus y0 equals mx minus x0. Hope that makes sense. So y minus 0 equals minus 3/4 x minus 4. Open brackets, y equals minus 3/4 x plus 3. Lovely. And that's the equation of the tangent. Equation of the tangent. Tangent. Okay. Lovely. Number 7. Median of a triangle. The vertices of a triangle are these. Find the equation of the median from vertex A to side BC. A median is a line segment joining the vertex to the midpoint of the opposite side. So once again, you don't have to draw the exact coordinates. It can help. Sometimes it's just an unnecessary complication. So A is 1, 8. B is minus 3, 4. and C is 7, 2. We want to find the median from A. So the median is this line from A to the midpoint. So let's call this midpoint M. And we know how to find the midpoint. Midpoint M is x1 plus x2 divided by 2, y1 plus y2 divided by 2. So basically it's the arithmetic mean, or it's the mean of the coordinates. So 7 minus 3, 7 minus 3 over 2, and 2 plus 4 over 2. So M is 4 over 2, that's 2. And 2 plus 4 is 6 over 2, that's 3. So it's 2, 3. Okay. And find the equation of the median. Yes, the median is a line segment joining the vertex to the midpoint of the opposite side. Perfect. And okay. Now we have AM. Well, there's another clever equation you could use for a line passing through 2 points. A line passing through 2 points. Passing through 2 points. It's if you have point x1, y1, and a point x2, y2, then you could do y minus y1 divided by y2 minus y1 is equal to x minus x1, x2 minus x1. There are variations of this formula. You can switch them around. You can write y minus y1 over x minus x1 equals y2 minus y1 equals x2 minus x1. These are equivalent. I I don't have a personal preference. I just use whatever comes to mind first. And so line line AM. So we're going to use the formula y minus y1 divided by y2 minus y1 is x minus x1 divided by x2 minus x1. So from here, it's y minus 8 divided by 3 minus 8 equals x minus 1 divided by 2 minus 1. So we have all we need. So we have y minus 8 over minus 5 equals x minus 1 over 1. So it is x minus 1. Multiply everything by negative 5. So y minus 8 equals minus 5. 5x plus 5. Y equals minus 5x plus 13. And that's the equation. That's the equation of the straight line. Okay. Angle between a line and a horizontal vertical line. Vertical line. All right, so we have a line with equation 2 plus 3y. So x, y, x plus 2 root 3, root 3y is 6. I'm going to use the trick again rather than trying to if x is 0, if x is 0, then y is 6 over root 3, which is 6 root 3 over 3, which is 2 root 3. So 0 to root 3, so that's approximately 3.4. So 2 root 3, which is approximately 3.4. And then if y is 0, then x is 6, of course. And that's, if this is 3.4, so 6 is approximately here. And so this is a straight line going like that. And then line L2 is the vertical line. X equals -2. So x equals 2 is a vertical line. So we want to find the angle between the lines. It doesn't specify which angle. So we're just going to, well, we're going to stick to this one angle, theta. And of course, if you draw this angle, you know that this is 90 degrees. 90 degrees. And this angle, we already know that's minus arctan of the gradient. No, minus arctan of the gradient. And the gradient of line L1, gradient of L1 is, so what's that? So y root 3 y equals minus x plus 6. Y is minus 1 over root 3. X plus 6 over root 3. So y is minus root 3 over 3, x plus 2 root 3. That's the equation of the line. So the gradient is arctan, minus arctan root 3 over 3, which is minus arctan minus. And arctan root 3 over 3, that's 30 degrees. So that's 30 degrees. So 90 plus 30. So the angle is, of course, 120 degrees. And so it's 120 degrees. And yeah, that's about it. Okay. Any questions? Any questions? We finished slightly faster than I anticipated. It's not bad. Mhm. Problem 8, how do you know if they're referring to the obtuse angle? Well, you don't. You just give the one angle that you found, and it should allow both. If you reflect a parabola or something, some other line or curve in a straight line, how do you find the equation of the new curve? If you reflect a parabola in a straight line, how do you find out the equation of the new curved line? Well, it depends on the line that you're reflecting it into. If it's a horizontal or vertical line, okay, let's answer that question. Yeah, by all means use Desmos. Yes. What are the questions that we do in the webinar source form? Well, various sources. I use old textbooks. Yeah, different webinars, different sources. If you reflect a parabola on some other line or curve in a straight line, How do you find out the equation of the new curved line? So let's see. Reflect the parabola. So if you have x, y, if you have a horizontal line, so if you have a parabola and you have a vertical line, for example, so x equals a. If you reflect that parabola in that line, well, that's just equivalent of moving it, right? It's equivalent of moving it to the left by a distance. Well, if the center of the parabola was here, if this is B, this was the vertex, this is the new vertex. So new vertex is B minus double the distance from B to A. Yeah, okay. No problem to the acute angle. Problem 8, how do you obtuse acute? Yeah, okay. If it's vertical, it's a vertical reflection, then well, it's going to be a flip and then a movement. So you just need to find the equivalent transformation, if that makes sense. You find the equivalent transformation, then you can do it. Because reflecting it straight away, um, well, you could do it straight away, but yeah, sorry, a bit. Is that what you're referring, Kevin? Is that what you were asking? How to do this? Or are you asking a different question? Are you referring to any particular problem, maybe? If the line was slanted, reflect a parabola if the line was slanted. Okay. Well, what I would do a rotation first. I would rotate the whole image such that the parabola is now vertical. Oh, sorry, the line is now vertical. And then I would do a reflection, and then I would rotate it back to the original position, if that makes sense. So I would apply a series of transformations. I would say, okay, so imagine I have a parabola, which is like this. And I want to reflect that parabola in the line. I want to reflect that parabola in this line, right? Okay. So what I would do in this particular case, so I would first rotate the parabola like this. So now the line is vertical. Then I would, so this transformation is a rotation. Then I would create a mirror image of that parabola. and then I would rotate it back. So I would apply 3 different transformations here. I hope that makes sense. Is that from the assignment? Sorry, I don't remember that question. Let me just double check. Um, okay. Which question was it in the assignment? Is it question? Well, look, you need to apply you need to apply a rotation first, and the rotation is well, you use this method. So if you have a point like A, B, then the new oh should have done it differently, right? And then a backwards rotation. Then I rotate it back to the original. Right. So first, I want to, if the coordinates are A, B, then the new coordinates, A1, B1. So A1, B1, B1 is the matrix of rotation, and that's cos theta is the angle of rotation. Then it is cos theta sine theta minus sine theta cos theta multiplied by by AB. So if this is the vertex, so A0, B0, then you do a reflection, then you get the image of A2, B2. Well, A2, B2 is easy. A2, B2 is simply minus A1, B1. And then you rotate back to get A3, B3. To get A3, B3, A3, B3, you multiply the backwards rotation. So it's cos minus theta, minus sine minus theta, sine minus theta, and cos minus theta. And you get the coordinates and multiply it by the coordinates of A2, B2. Sorry. I know you're probably unfamiliar with the notation, but that's how you do it mathematically. You'll need to look up matrix of linear transformations, right? This is from further maths A level, right? A0, B0 is the original coordinates of the vertex. A0, B0 is the original coordinates of the vertex. Um, so A1, B1 is the coordinates of the vertex after the first rotation. Then A2, B2 is the coordinates of the vertex after the reflection. And then A3, B3 is the final coordinates of the vertex of the reflected parabola. Okay, I'll have to stop here. Thank you for your attention. Thank you for all your questions. Yes, I'll see you all. Oh, see you all in the new year. I think that was the last one for this year. Let me double check. And um, webinars. The next one is the 5th of January. All right, all the best. Have a lovely Christmas and lovely New Year, and I'll see you.